Hello guys, what's up? This is Dave. Today we'll learn about friction and solve some questions, okay? So what is friction? Many of you have heard it, and people say basically definition of friction is that it opposes motion. Okay, well this is not the definition because friction opposes relative motion. Just remember. Okay, friction always opposes relative motion, alright? So you see, if a block is here lying on a surface and if I pull this block with a force F, suppose the block has mass M and here friction is there. So the friction will try to stop the block, and since it is going here, the friction force will be like this. Consider it to be small f, alright? So it has opposed the motion. General people will say, alright, what about this? If a ball is rolling, say cylinder is rolling, then where will be the friction? Friction will be in the forward direction, it will not be in the backward direction. And people will say it is rolling forward, it should be in the backward. No, it is in the forward direction because friction is opposing relative motion over here. You see, at this point P, the tendency of ball is to rotate. This means the tendency of ball is to slide along this surface along this direction. Due to this tendency, the surface having friction over it will oppose this tendency of ball to slide along this direction. So it will put a force over here so that this tendency to slide is opposed. Hence the friction force will be forward direction. Okay, so let us solve. First of all, I want you to know what is how we calculate friction. You see, there is one thing called coefficient of friction. It is generally written as mu. Okay, so there are 2 points over here. Consider a force F and this has friction. So this surface has friction. The force is time dependent. Okay, in general the force along with time increases. Okay, like this. It has no specific equation, only just for demonstrative purpose I am solving this. And normally, since it is increasing, at one point will come when the block will start moving, because initially if it is very less, then friction will oppose the motion of block, and for quite a long time the block will remain static. Due to it being static, the differences in force will not generate acceleration, so it will be m into 0 since the block is static. Alright, say t naught, so f at t naught equal to f. Okay, this is the point. You see, this is the time t naught. This is the time t naught till the block was static. Okay, so the friction force is this. Okay, now the block starts moving as the force has risen. Okay, so at any time t, the block has moved. Now also friction will act. Okay, don't think that friction will be invisible now. Friction will also act now, but this will be a different friction. Let us call it Fk. So the different friction will be this, like this. Here acceleration will be generated and friction force will be different. This Fk will not be equal to F. Okay, and this is Fs, say, because this is static, this is kinetic. So you see, Fk is not equal to Fs. This is because there are two coefficients of friction. One is static coefficient. This is static coefficient. Okay, and one is kinetic coefficient. Alright, another thing is that friction as such, the formula for friction force is the coefficient of friction into the normal force on the block. Okay, this is the formula for friction. Alright, as friction actually depends on the area of contact also. So the normal force also comes into play, and if we draw a free body diagram of M over here, you see there are only two forces, N and mg. If a force F is applied, obviously there is one force F and there is this force F, friction force. Okay, So vertically the forces are balanced because the mass is not moving vertically. So N will be equal to mg. So what will be F? Friction force will be equal to coefficient of friction multiplied by the normal, which is mg. Okay. So coefficient of friction will be equal to mu mg. So what makes this friction a static friction? Because the block is not moving. So Fs equal to mu s mg. This coefficient of friction, this coefficient of static friction will make this friction force static. And another Fk will be equal to mu kmg. Okay. This coefficient of kinetic friction will make this friction force a kinetic friction force. Alright. In general, mu s, actually in general I think mu s is not equal to mu k, because you know the kinetic force of friction will not be equal to the static. Alright. Please find out whether mu s, I think mu s is greater than mu k. Okay. Mu s I think is greater than mu k. Alright. So let us solve one question. Suppose this is an inclined plane. This is an angle theta. This is one block of mass m1 and this is attached to a pulley. And this rope is running and this block of mass m2 is free. Alright. This pulley has friction over it. Okay. And I say suppose the coefficient of friction is mu. Alright. Now this is static and kinetic both. Alright. Now we'll first separately find the static and then kinetic. Okay. You see, in the case of static friction, what will happen is this block M1 will remain static. Okay. So we draw the FBDs or free body diagram of individual masses. Let's say M2. There are only two forces, M2G and T. Okay. So since they are static, this means M2G will be equal to T. Alright. Now let us draw the free body diagram of M1. There is the tension over here. There is this normal and there is this weight. Because weight is vertical, there will be two components of weight. This will be mg cos theta because this angle is theta. So, and this will be mg sin theta, right? And this will be the static friction force. Okay. So T would be equal to mg sin theta plus the static friction because the block is static right now. Okay. And as I earlier told you, the rope is massless and non-stretchable. Alright. So tension will be same and acceleration will be same. T is same and A is same. Alright. I have explained this in my earlier video. So, and Fs would be equal to mu s into n, as I explained earlier. So what is n over here? N here is mg cos theta, right? So Fs would be equal to mu s mg cos theta. We put this into this equation. T becomes equal to mg sin theta plus mu s mg cos theta. Alright. And this will be m1g. Okay. So T becomes equal to m1g sin theta plus mu s m1g cos theta. And T was earlier equal to m2g. So we can equate these two. We have m2g equal to m1g sin theta plus mu s cos theta m2g. Gg gets cancelled out. So m2 by m1 equal to sin theta plus mu s cos theta. Alright. This is the ratio of mass when the friction is static. Okay. Now suppose the blocks are moving. This was m1, this is m2. Now suppose they are moving. So now what will be the acceleration? First equation is m2g minus t equal to m2a. Second equation would be t is over here, m1g sin theta. This would be fs, m1g cos theta, and this would be n. So this would be t minus m1g sin theta minus, and this would not be fs, this would be fk now, mu k mu k m1g cos theta equal to m1a. Alright, we add these two, tt gets cancelled out, so we have m2 minus m1 sin theta plus mu k cos theta whole multiplied by g divided by m1 plus m2. Okay, this is the acceleration. Alright, in a normal situation, you see, in a normal situation, for example, if a force is pulling a block and there is frictional force, we generally write F minus F equal to mass into acceleration. What if the force has an angle to it? For example, let us say F had an angle to alpha. F had an angle alpha to it. Now what would happen? Now F would get distributed into two components. One would be the vertical and other would be the horizontal. So this would be F cos alpha, this would be F sin alpha, right? This would be the normal, this would be the weight, and this would be the friction force. So if say it is not accelerating right now, so we have F cos alpha equal to F, alright, which is equal to mu into n, and the vertical equation stands for mn plus F sin alpha equal to mg, right? So what is n over here? Mg minus F sin alpha, and we put this in this equation, we get F cos alpha equal to mu times mg minus F sin alpha, and from this equation we get F equal to mu mg upon cos alpha plus mu sin alpha. Alright, now the equation of force was F equal to mu mg divided by cos alpha plus mu sin alpha, right? And this was the figure. Okay, so now I want to find out at what angle alpha will the F be maximum. I want to find out this. At what angle alpha will the F be maximum? So for this, we just simply do a maxima minima calculation. First we differentiate F with respect to alpha. We get mu mg, and this is constant because denominator is not constant, so this will be minus sin alpha plus mu cos alpha divided by cos alpha plus mu sin alpha, the whole square equal to 0. And we also have to calculate d square f by d alpha square. Okay, you see I have written here maximum. It can also be minimum if only if d square f by d alpha square is greater than 0, then it will be minimum. If d square f by d alpha square is less than 0, alright, if d square f by d alpha square is less than 0, then it will be maximum. You have to check it for yourself. Okay, do not go by the by my verdict that this will always be maximum. This can be minimum also. You have to check. Okay, you please check. Okay, in questions sometimes people do mistakes. For example, there is three option, and we have to calculate maxima. All right, there is 1 2 3 options are given for maxima, but the fourth option is none of these. Okay, what will people do is they will not calculate this double differential. They will write either of the three options and they will go wrong, because if this double differential comes out to be greater than 0, there can be no maximum value. There has to be a minimum value. So you have to mark it as 4. You cannot mark as the 1 2 or 3. So this is a very silly mistake people make, and you should not fall into this trap. Okay, so this differential df by d alpha was 0 for f to be either max or min. Okay, so what will be alpha? This will be 0 na. So minus sin alpha plus mu cos alpha would be equal to 0, and mu equal to tan alpha, and alpha would be equal to tan inverse mu. So for either f to be max or min, alpha has to be tan inverse mu. Just remember this relation. In questions, direct formulas are asked on this, and you don't have to do anything, you just have to calculate this. All right, but be sure, if you have to calculate maximum or minimum, please find out the second derivative of x. Do not just leave this thing. Okay, so now let us take another example. For example, now this is an inclined plane. All right, and instead of a block we have a cylinder rolling down an inclined plane. So what will be the equation of motion now when there is a friction on inclined plane and we have given the friction coefficient as mu? You see, let us consider this cylinder of mass m. So you see, this will be the weight. This will be the component of weight along the inclined plane. This will be the component of weight perpendicular to the inclined plane. Okay, and this would be the normal. Where would be friction here? Friction would be along this side. Alright, friction would be along the gravity, component of gravity. You see, friction will not be opposite. This, if you draw this as friction, this is wrong. Why? Because this is a cylinder, it is rolling here, so it has a tendency to slide here. Because friction opposes relative motion, the tendency to slide will be opposed by the inclined plane surface. Hence, the friction will act forwards direction. Okay, so we have mg sine theta plus f equal to ma. Actually, this will not be m, this will be I. I'll tell you how. Because center of mass is involved and rotational motion is going on, that's why this will be I. This cannot be m, but for time being I am taking this as m. Okay, don't get confused, this will not be m at all. Okay, just for demonstrative purposes I have shown this as equation. This will be equation of motion, and f will be equal to mu into n. N will be what? Mg cos theta. Okay, so this will be another equation of motion. Okay. Okay, so now let us take another question. We have an inclined plane and we have coefficient of friction as mu. A particle of mass m starts from point O with an initial velocity u equals 0. I want to find out the velocity at point A when the particle reaches the point A. The height given is h and alpha is the angle. So there is a standard method. Okay, first I will follow. Actually, consider it a very small block. Okay, it is not a cylinder. So this is the gravitational force, this is the component of gravity, and this is the component perpendicular to it. This is the normal, and obviously here it will be the friction force. Friction will be equal to mu n. Standard mg sine alpha minus mu n equal to ma, right? And n would be equal to mg cos alpha. Hence, mg into sine alpha minus mu cos alpha. This would be equal to ma. Mm gets cancelled out. Hence, and also now you see, initial velocity u was equal to 0. By the equation of motion, v square equal to u square plus 2as, right? And u is 0. A, we consider this distance as s. Okay, A was g sine theta, so v equal to actually no, we don't do this. You see, g into sine alpha minus mu cos alpha, right? This would be equal to v dv over ds, right? Now we can solve it. We take ds over here. Okay, so we have g into sine alpha minus mu cos alpha into ds equal to v into dv. Now we can integrate. Alpha is constant. Okay, so this will be from 0 to v of a, and this will be from 0 to s. So this will be g into sine alpha minus mu cos alpha s. This is equal to v square by 2. So this is 2g into sine alpha minus mu cos alpha s the whole root. And now this is s and this is h. What is s? You see, sine alpha is h upon s, right? So S equal to H divided by sine alpha. So we just put the value of S here and we get V equal to root 2 GH 1 minus mu cot alpha, right? Because we'll divide this by sine alpha by sine alpha is 1 minus mu into cos alpha by sine alpha is cot alpha, alright. Now we can also solve the same question by another method, but for that first I'll have to teach you work and energy, alright. This is a very important concept. Now what is the work done? The element work done is F dot ds. We all know that, okay. Work is a scalar and this is a dot product, so this is also scalar, alright. Now in general, if we see this dot product F dot ds, this can be written as M into A dot ds, right? This is a vector and this is a vector. You see, work is always force dot displacement, alright. So what is A? A is dV over dt, okay. Yes, A is dV over dt. So now we put this value of A here, so we get M dV by dt dot ds. Now we just take this expression. So V was ds by dt, everyone knows. So F dot ds would be equal to M dV dot V. Alright. So I had earlier taught you, in scalars A dot B is equal to B dot A. It does not matter in scalars, alright. Now, I mean, in scalar dot product, it does not matter whether A is written first or B is written first. The dot products of two scalars are same, okay. So M dV dot D can be written as MV dot dV, right? And this is the expression for elemental work done. This is the expression M dV V dot dV, alright. You should remember this. This is the expression. Now for a simple case, if a particle is moving in a straight line, V and dV are parallel, alright. If it is accelerating in a positive direction. So V dot dV would be equal to V dV. Alright. So we have dW equal to M V into dV. Now integrate this. This is from 0 to W and this is from, say, velocity was 0 at initial point and now this is V. So we have mv square by 2. Alright. So work done, or we can say if the velocity was Vi and this was Vf, so this was Vf square minus Vi square into m over 2. So we can say work done is always change in kinetic energy. Whether potential energy is involved or not, I am writing down here whether potential energy is involved or not. Work done is always change in kinetic energy. We should remember this. This is a very important concept, okay. Anyways, you will, can calculate work if you know the change in kinetic energy, alright. So what is this potential energy U? In general, U will only arise if force is conservative, okay. What is this meaning of conservative force? This F conservative means F is only a function of R. Say for example, this is a point O and this is F, okay. This F is a function of R from point O, alright. When this is R1, this F becomes FR1, and if F is here and this is R2, then F becomes F of R2, alright. So this conservative force is always a function of R. If this conservative force is there, then only potential energy arises, okay. Potential energy will only arise if force is conservative, okay. For example, you see gravity is a conservative force, alright, because the force is dependent on our general formula for gravity is force is proportional to 1 by r square, alright. And we can assume masses as constant and g as constant. So you see, in general it is proportional to 1 by r square. It means that force is only dependent on r, alright. If force is conservative, so if force is conservative, then the force can be written as minus del u by del r. Alright. This del is a partial derivative. You don't need to go into this. We will just assume minus du by dr. Okay. If we assume u as a function of x, okay, since we are dealing with one dimensional over here, but if three dimensions are involved, partial differential will come, okay. So if f is a conservative force, then only u arises, all right. And you know, the change in potential energy then becomes negative change in kinetic energy, all right, because the mechanical energy will remain constant. So if there is no other force and the force is conservative, then change in potential energy becomes negative change of kinetic energy, all right. So how does this happen? This expression is only valid for conservative force, as we all know, okay. So you see f dr equal to minus du, right? So for an elemental displacement, dr becomes ds, all right. Suppose a particle is at point 1 and then it goes to point 2. Don't consider point 2 over here, it is very large. Consider point 2, which is at a very small distance, delta r, okay. So this is r1 and this is r2. If it is going from 1 to 2, okay, so the velocity will be delta r by delta t. Just remember, velocity is the displacement, okay. And if we limit this, if time is taken as very small, this will be equal to dr over dt, alright. And now since v equal to dr over dt, so v dv by dr would be equal to the acceleration, since dv by dt is acceleration, okay. Since dv by dt is acceleration, so v dv by dt will be the acceleration also, because we can split this dv dot dr by dt, this by dr, this would be equal to v and this would be v dv over dr, okay. So now we can use this expression in this, this is not dot product, okay, minus del du, okay. So we know that f dr is v dv by dr, so v dv gets cancelled and we arrive at an expression delta ke equal to minus delta u, okay. So ke1 plus u1 equal to ke2 plus u2. This means whatever the kinetic energy at 1 and potential 1 if summed up, and whatever kinetic energy at 2 at potential at 2 if summed up would be equal. Why? Because force is conservative, alright. Here I have assumed a conservative force. Just please remember this, conservative, it is very important, otherwise potential won't exist, okay. Now now I take one question. For example, this is a circle, all right, and now the particle starts from this point. Say this point is A and reaches this point, all right. This is B and this is R. R is the radius of the circle, R is constant, okay. Now I want to know at this point the velocity of a particle was V. This point it is V, mod V is constant, and this is a proper uniform circular motion. Uniform means velocity is constant, alright. There is no acceleration except the centripetal acceleration, which I proved earlier, alright. So I want to know the work done from A to B, alright. So first method was, which I earlier taught you right now, it was mv dot dv, right. Since v is tangential, the rate of change of v will also be tangential, alright. So since for any curve, if r is decreasing or increasing, for example this is r, this is r1, this is r2, the displacement will be very small, and from point A to point B this will be the straight line between A and B. And if it is very small, this will be approximately tangential to which is parallel to velocity. Hence mv dot dv will be equal to mv dv, alright. What is the work done in A to B? So what is the velocity from A to B? V at A is V and V at B is V, alright. So this would be 0. So work done in a circular motion is always 0. Another method, work done was F dot ds. Alright, force dot displacement. Now force dot displacement, you see displacement is along, for example, if you take a point O. What is the displacement? Displacement is AO. But we only know that centripetal acceleration is acting, hence force will be directed towards the center. If we take, if we take it to be very small, so AO will become tangential. AO will be tangential. And when AO is tangential, R is perpendicular to the tangent. R is perpendicular to AO. So F will be perpendicular to ds. So F dot ds would be equal to F ds cos 90. And cos 90 is 0, so work done would be equal to 0. Alright. Work done would be equal to 0. Since dw is 0, we can say that work done at A equal to work done at B. Alright. Whatever you want to call, the work done in a circle is always 0. Okay. Now we head back to the same question. We had an inclined plane of angle theta. A particle was, suppose that O, this was A and this was B, and this is mass m. Alright. And now particle started with an initial velocity 0. I want to find out the velocity at A. Friction coefficient is mu. Okay. So we solve this in a different method. So what will be the total work done? What will be the total work done here? Since particle is traveling, friction will also do work because friction will oppose the motion. So work done by friction, yes, and work done by gravity. These will be the two work performed by two forces, frictional force and gravity force. Work done is the change in kinetic energy. Okay. So net work done would be equal to the change in kinetic energy. Kinetic energy at A minus kinetic energy at B. So what is the work done by friction? Since friction is applied here, F, which will be equal to mu into N, and N was perpendicular to the surface, which was equal to mg cos theta. This was mg and this was mg sin theta, right? And this was the frictional force. So work done by friction would be, F into AO, this distance. Alright. And this will be negative because, displacement is OA. So F dot OA will be the work done by friction force. And since these are anti-parallel, so this would be equal to minus FOA. Alright. And work done by gravity would be equal to mg sin theta times OA. This is okay. Alright. So what is the net work done? Net work done would be equal to, what is friction? Mu mg cos theta. So minus mu mg cos of theta times this. Suppose this is S. Okay. This was H. And plus mg sin theta times S. Okay. So net work done is mg sin theta minus mu mg cos theta times S. Right. This is the total work done. So this would be equal to mg into sin theta minus mu cos theta into S. This is equal to W. We know for sure work done is change in kinetic energy. At point O, velocity was 0. At point A, suppose it is VA. So the only kinetic energy change would be equal to half mVA square. This would be equal to sin theta minus mu cos theta into S. Alright. So what was S? This is H and this is theta. So tan theta equal to H over S. Alright. So this gets cancelled out and VA square would be equal to 2g sin theta minus mu cos theta S. Sorry, tan theta. No, this will not be tan theta. This will be sin theta. Yes. Alright. sine theta equal to perpendicular by hypotenuse. So sine theta would be equal to h upon s, right? So s would be equal to h divided by sine theta. So we just put this here, 2g into sine theta minus mu cos theta into h divided by sine theta, and we take this root, and we have the final formula for VA as 2g into, this would be h, this would be 1 minus mu cot theta, and this is the exact answer we got by the force, the concept of acceleration. This is the exact answer we got from the concept of acceleration. Alright, what I want to emphasize over here, because this was a straight incline. For example, what if this incline is like this? This is point A and this is point B and this is the height h. Now suppose this does not have friction. Alright, mu is 0. And particle starts from A with an initial velocity 0. I want to find out the velocity at B. So you see, friction is 0. Friction is a non-conservative force. Just remember this. Friction is a non-conservative force. Friction will not depend upon the reference point as potential energy does. Potential U is due to conservative force. Alright. And gravity is a conservative force. I already told you the gravitational attraction is proportional to 1 by r square. So gravity is a conservative force. I'll explain you later. Alright. Called gravity. Now you see, there is no non-conservative force at play. There is only one force, which is mg. This is at play. And so potential energy will be generated over here. Alright. Because of a conservative force mg at play. Now, since conservative force is at play only, so I can use the equation which I derived earlier, Ke at A plus U at A equal to Ke at B plus U at B. This is the equation I derived. Okay. Now for potential energy, I need a reference point. Alright. I need a reference point. Either it can be infinity, because potential U is defined by a reference point. For potential energy to be defined, for example, I want to define the potential energy U at 1. I will take infinite as my reference point and I will take this as U equal to 0. Now from infinite, if I bring a particle to 1, alright, then if there is a resisting force, then potential will be generated. Or from 1 I take the particle to infinite. If there is force in the opposite direction, then potential will be generated. Alright. So I need a reference point for potential always. So I am taking B as reference point. Okay. And I am taking B as potential energy at B is 0. I am taking this. Okay. Since F equal to du by dr, alright, and if we just consider the weight mg, we see that at point A, F du would be equal to F dr, right? And we integrate this. What is F? F is mg. And the particle, instead, you see, when the particle is coming down, it is gaining kinetic energy, right? And losing potential energy. Why? Because this was the original figure. This is point A, this is point B. At point A, U equal to 0. I want to find the velocity at B. Now you see, when it comes down, it is gaining energy. Similarly, it will lose potential energy when it comes down. Why? Because the change in kinetic energy is negative of change in potential energy, as I told you earlier. So, since at A U is 0, obviously it has gained kinetic energy because velocity is increased at B. Alright. So, this is H, say. So, I am taking the potential at B to be 0. U at B to be 0. I will only take the potential at A. General formula for potential energy is mgh. Okay. So, potential at A is mgh. Alright. Potential at A is mgh. And potential at B, I have assumed this as 0. Alright. because particle comes to rest here. Alright, from here it will lose some energy, then only gain kinetic energy. What is that energy which it has lost? In conversion to kinetic energy, it has lost potential energy, and now it has velocity, and it is at ground. Alright, this is ground. So the change in kinetic energy, what will the change in kinetic energy be? This will be equal to half mv b square minus half mv a square equal to negative change in potential energy. What does negative change in potential energy means? What will be the change in potential energy? 0, negative of ub minus ua, right? ub is 0 minus, what was ua? mgh. So this will get cancelled out, and I know for sure va is 0. So what will be vb? vb will be equal to root 2 gh. Just by knowing the height and the velocities, I have arrived at an expression of the final velocity just by knowing the height, you see. So it is very useful in competitive exam. They ask such type of question, they'll make this kind of inclined plane, and you'll just get confused what to do with mg sin theta angle and everything. You don't need to go into these things, you just need to go into the equation of energy and solve it as I have solved. Alright, now I take a question. Here friction is 0. Okay, let us consider friction to be 0 first. Alright, now a particle m starts moving with a velocity varying with distance. Alpha root x is the velocity. Alright, it is moving in a straight horizontal line. Find the work done by the particle in time t. Alright, so work done, as such, I gave you the definition. Work done was mv dot dv. This was the definition of work done, or f dot ds, whatever you want to call it. Okay. Now what is v? V is alpha root x. What will be dv? dv will be equal to alpha by 2 root x dx. Alright, this will be equal to dv. dv will be equal to, let us take another question. This is a frictionless surface. Okay, mass m is moving with a velocity varying with distance in a straight line, v equal to alpha root x. I want to find the work done in time t. This is very easy. You see, I told you earlier dw was mv dot dv. This is the basic definition of work done, or we can say f dot ds, whatever you may want to write. Now v is given. Alright, v is given as alpha root x. So what will be dv? dv will be equal to alpha by 2 root x into dx, right? So we just multiply the two. Since v and dv are in the same direction, it is accelerating, hence v dot dv will be equal to v dv. M alpha root x times alpha by 2 root x, and this would be equal to dx, right? This gets cancelled out. M alpha square by 2 dx. This would be equal to dw. Now velocity equal to alpha root x, right? So in time t, in time dt, velocity will be equal to dx by dt, right? Alpha root x. Now what will be the x covered in time t? So you see, dx by root x equal to alpha dt. We just integrate this from 0 to x, from 0 to t. We have alpha t equal to 2 root x, and x would be equal to alpha square t square by 4, right? So just we integrate this expression and we get m alpha square x by 2 equal to work done. We just put the value of x. We have m alpha 4 t square by 8. This is the answer. Okay, now suppose friction is there and the body starts with a velocity v naught. Alright, so obviously the body will feel a retarding force, which is friction force. Okay, this will generate an acceleration ma, right? So what will be the friction force? We draw the free body diagram of the body. This is normal, this is mg, and this is f. F would be equal to mu times n. This would be equal to mu mg, right? And you see, acceleration will not be there here because initial velocity is v naught in this direction. Hence, there will be a deceleration. Alright. And since force produces mass into acceleration, the deceleration will be equal to mu times g. Alright. So we can say the final velocity would be equal to initial velocity v naught minus mu g into t. This would be equal to the final velocity. Alright. This will be the final velocity. Since force of friction is generating an acceleration a equal to minus mu g. Alright. So I now want to find out the work done. What is the work done by the body in time t? You see, the basic definition of work done is change in kinetic energy. Basic definition of work done is change in kinetic energy. So this will be half mvf square minus half mvi square. That's it. Because in time we have to calculate work done in terms of time t. So just we put the value of vf and vi and we get the work done. Alright. This will be like this. Minus half m v naught square, right? We can just take out half m. A square minus b square would be called a minus b. A minus b, this will result in mu gt into a plus b. This will result in 2 v naught minus mu gt. This is the work done. Alright. In time t. Another method for finding the work done, which I can show you, is, for example, this is the mass, this is the frictional force, and this is the velocity v naught. Alright. So another method of finding the work done, since friction is the only force here, because normal is balancing mg and particle is not going down, hence the weight we will not consider here. So the work done by friction alone would be equal to F dot S. And since displacement is in the positive direction, friction is in the negative direction, hence we have this minus Fs. And now what is the value of F? F was mu into N. N was mg and this is S. Alright. Now, what is S? It is a displacement. So what is the final velocity Vf? V naught minus mu g into T, as friction has caused a deceleration of the body, right? And Vf would be equal to ds equal to V naught minus mu g into T dt, right? In time t, body will cover a distance s, and this is equal to V naught T minus half mu g T square, right? We just multiply this. Look what we get. Minus mu mg, right? V naught T minus half g mu T square, right? What is this then? You see, T can be out and we have minus mu gt. We take half out, so, and we have 2 V naught minus mu g t. This is the exact expression I got. Okay, I just forgot to add m in the previous expression. So now we take another example of simple pendulum. You see, simple pendulum is taken at A, and it is, free. It is freed at A, and then it goes along this trajectory and reaches B. Okay. So at A, its initial velocity is 0. I want to find out the velocity at B, V for example. Okay, I want to find out the velocity at B. So how do I do this? We just, we can do this by two methods, but first I'll tell you the energy method. Okay. So in this method, first we will take a reference point. Why? Because only gravity is involved here. Gravity is a conservative force, and since you see, tension is also involved, yes, but tension will not do any work here. Why? Because the displacement is along the tangent. You see, in a very minute displacement, for example, if a pendulum is like this and it is taken at this point, if it displaces a little, this little part is almost the tangent, and tension is along the perpendicular to the tangent. So tension does no work. Okay, tension will do no work over here. Only work done is by gravity. Okay, so conservative forces is only gravity and work done is by gravity, hence potential energy is here. Okay, it will be generated in this, in this question. Okay, all right. So this was the figure. This is point A, this is point B. I have assumed the point B as reference point where U, this is potential at B, is equal to 0. Okay. So this is the B is the reference point for potential energy. Okay. Now I want to find the velocity at B. Alright. So we take the energy equation Ke at A plus potential at A would be equal to Ke at B plus potential at B. Why is this? This is because only conservative force is involved here, which is gravity. I told you tensile will not do work because tensile is perpendicular to the displacement by the bob. Okay. So T dot ds will always be 0. No work done by tension, work done only by gravity. First I am taking the energy method. Okay. So the kinetic energy at A was 0 because U at A is 0. Velocity at A is 0. What is the potential energy at A? You see, potential energy, if I measure with this reference point, this is the height h. Alright. So potential energy at A would be equal to mg into h is equal to kinetic energy at B half mvb whole square, right, plus potential energy at B will be 0 because B is the reference point. I have already written U of B is 0. Okay. What is this h? You see, this is theta. This whole is L, right? This is also L. Now I want to find out what is h, right? So how do I do this first? You see, this part, if I assume this point is O and this as P, so you see O, this point is B, right? And so you see OB equal to OP plus PB. What is OB? This is the full length. What is OP? We don't know yet. And PB is H. So L minus H would be equal to OP, right? Now this is the right triangle. OPA is a right triangle. Okay. So what will happen here? I take cos theta. Cos theta is base upon hypotenuse. So this is the figure. This is O, this is P, and this is B, right? This is L minus H, this is L, and this is H, and this is theta, and this is A. So triangle OPA is a right triangle. This perpendicular is for right angle, and this is triangle, right? So cos theta would be equal to L minus H by L, right? Because cos theta is based upon hypotenuse. You must be knowing this, okay? Anyone can tell. So L cos theta equal to L minus H. H goes over here, L into 1 minus cos theta, right? H equal to L into 1 minus cos theta. So we put the value of H in the expression. mgl 1 minus cos theta equal to half mvb square. Gets cancelled out. What is vb? Vb equal to root 2gl 1 minus cos of theta. Alright. This is the velocity at B. Okay. Now we try another method. This another method is by the work done. You see, this is the small angle theta. This is L, this is L. Alright, this is point A, this is point B. So the displacement is towards this point, right? A obviously is coming towards B. So since displacement is towards this point, what are the forces on A? First, let me know this. Forces on A is mg, and another force is the tension, right? Tension is being balanced by the component of gravity. Since this is theta, if we take a parallel line, this is 90, this is 90 minus theta, right? And this should be theta. Alright, since parallel lines and these are the alternate angles, so theta. This theta angle is contained between these two lines, so this should be theta, and the component of mg towards this line should be mg cos theta, and perpendicular to this line should be mg sin theta. So work done is only by mg sin theta because T is getting balanced. Okay. balanced by mg cos theta. Hence no work done by that force because it is balanced. Only work is done by only mg sin theta does work. Alright. So what is the work done by mg sin theta? You see, for a very small displacement, for example, this is the displacement by A. This is a distance ds, right? Obviously ds is tangent, mg sin theta is also along ds. And say this is an angle d theta. Okay. So elemental work done by mg sin theta would be equal to mg sin theta dot ds, right? Obviously mg sin theta and ds are along same direction, so this dot gets we can omit this dot, and this is the expression mg sin theta ds. And for a very small angle, you see ds equal to r d theta in any arc containing very small angle, okay, d theta. This is ds and this is r and this is d theta, so ds equal to r d theta. What is r here? R is L, so dw equal to mg sin theta L into d theta, right? So dw equal to mg L sin theta d theta. Now we integrate this. We have to integrate this. What is sin theta d theta? How do we calculate this integration? You see, differential of cos is equal to minus sine. Everyone knows. We take d theta over here. D of cos theta equal to minus sine theta d theta, right? We just integrate this. Minus sign comes over here, so minus cos theta plus c equal to sine theta d theta. This is the integration of sine, which is minus cos, okay? Minus cos is the integration of sine, right? So w equal to, this will go from 0 to theta, integral 0 to theta mg into minus of cos theta. So just we put the limits here, 0 and theta, mgl actually, mgl into minus cos theta. Yeah, we can first take minus outside, so this will be cos theta minus 1, and multiplying it with minus sign we get mgl into 1 minus cos theta, right? This is the work done. Now what is work done? Work done is the change in kinetic energy, which I already told you. At A velocity was 0 and at B velocity is Vb. So change in kinetic energy would be equal to half mvb square equal to mgl into 1 minus cos theta. Okay. So Vb equal to root 2gl into 1 minus cos theta. This is the exact same answer which I have arrived earlier. So you see, you can do it by any of the method, energy or force method. You can apply any method, the answer will be same. It has to be same. Okay. Now we take another question. A body is thrown upwards with the velocity v0. Okay. And air drag is here now. The air is resisting the body's motion. Okay. And the air drag force is equal to kv square. Now I want to find out the total distance body covers in going up and coming down. Okay. So going up, let's say S1, coming down, let's say S2. What is the total distance covered? S1 plus S2, I want to know this. So how do we do it first? You see, when a body is going up, what are the forces on body? First, always remember to draw the forces on body. Forces on body are the weight, yes. And when it is going up, the air drag will resist this motion. So it will try to push the body down. So what will be the force of air drag? Kv square. Okay. And the total of this force will cause a deceleration. Since the deceleration is there, so A will be negative. The total A is negative because of deceleration. What is ma? Equal to minus of mg plus kv square. Okay. Now this is the equation of motion. So we just divide by m, we get A equal to minus of g plus kv square by m. Okay. This is the first equation. Now what do we do? A equal to v dv by ds. We know that minus of g plus kv square by m. Okay. So we get v dv by g plus kv square by m. right, equal to minus of ds. Now this is from v0 to 0. Why 0? Because body will stop at some point and then it will start going down. Okay, so we just integrate this from 0 to s. So this expression, first of all, let us say, you see I am showing you now how to integrate. Let us say g plus kv square by m is z. Now we just differentiate it. G is constant, so it goes out. What is the differentiation of v square? V square will be equal to twice v dv. This will be equal to dz, right? We take this v dv common. So what is v dv? V dv equal to m by 2k dz. Okay, so just we put the value of v dv over here, and g plus kv square by m was z, so we get m by 2k dz by z. What will be the limits? You don't have to now write v0 to 0 because that was the limit of v. Here we have taken the expression in the form of z, so limits will change now. You see, when v was v0, then z was g plus k v0 square by m. So limit will be g plus k v0 square by m to, now when v is 0, z is simply g when v equal to 0. So this is g. Now we have the expression equal to s, right? So dz by z, the integration is log of z. Okay, so we have m by 2k dz by z g plus kv0 square by m to g equal to ds. The integration of dx by x is always log x. Okay, plus c, because limits are not here right now. Dx by x, the integration is always log x. You should remember this. Okay, so we take this as log of z, put limits. So we have log of g minus log of g plus kv0 square by m. This whole expression is times m by 2k. This is equal to s. So you see, log EA. What is log EA actually? Log EA is actually, log, for example, I should say log EA is a standard form actually. For example, if I say what is log AB? Log AB is log of B, okay, divided by log of A. We can also write this log of B divided by log of A, okay, and also log of log EA minus log EB. We can write this as log EA by B. We can write this as also this, okay. So log of A minus log of B is written as log of A by B. Remember this. Log of A minus log of B is written as log of A over B. The whole log, okay, not individual logs like this. This log of A, B can be written as like this. Individual log of B by individual log of A. Log base A, then expression B can be written as individual log of A, log of B by individual log of A, okay. This log EA is a standard form where E is the exponential form, okay, and E is standard. This is standard notation of log, okay. So now this expression will reduce to m over 2k log of g divided by g plus kv0 square by m, okay, and this is s, and this was minus m by 2k, and this is log of 1 we are dividing this by g. We have 1 plus kv0 square by mg equal to s. So s equal to log of a by b, okay. The whole log of a by b is log of 1 minus log of 1 plus kv0 square by mg. This whole expression multiplied by minus by m by 2k. Log of 1 is 0. Log e is a standard form, okay, just remember it. Log e of 1 is 0, okay. So s1 actually is equal to m by 2k log e 1 plus kv0 square by mg, okay. Now a particle will come down. Okay, when the particle has traveled this much distance s1, it will come down obviously, but it will travel the same distance s2. Okay, so s1 equal to s2, anyone can tell. Okay, so I want to know the final velocity of the particle now. What is the final velocity? Because the net distance would be equal to the twice of s. Whatever it goes up and covers the distance, the same it will cover when going down. So total distance s equal to s1 plus s2, because both are same, this will be equal to m by k log 1 plus kv naught square by mg. Now when the particle is coming down, it has zero velocity because it has stopped at this point. I want to find the velocity at the bottom. So you see, when the particle is coming down, the forces acting on it are the weight. First force is the weight, yes. Next force is the force of air drag. Force of air drag will be applied in such a manner as to resist the motion of particles. So it will be applied now up, because particle is going down, so to resist it, the force of air drag will be upwards. Net force on particle will be equal to mg minus kv square. This will be positive because particle is accelerating now, it is not decelerating, as opposite to the first case. Okay, so a would be equal to g minus kv square by m, right? Now since a is g minus kv square by m, we have v dv equal to g minus kv square by m into ds, right? And this expression can come down. We have v dv by g minus kv square by m equal to ds, and we integrate this now from 0 to v. We don't know the final velocity now, and this is from 0 to s. Okay, s2 actually, s2, and this s2 is equal to s1. Remember, okay, we assume g minus kv square by m equal to z, and now we differentiate this. G is constant, it goes out, we get 2k v dv by m equal to dz, and v dv would be equal to m by 2k into dz. Alright, just putting this expression over here. Now you see, when velocity is 0, z is equal to g, this gets out, and when velocity is v, z is equal to g minus kv square by m. So we have now m by 2k dz by z integration from g to g minus kv square by m equal to s2. Alright. So m by 2k dz by z integration from g to g minus kv square by m equal to s2, and we know this is log z, so we have log of g minus kv square by m minus, and this was positive, yes. Okay, g minus kv square by m, no, this was actually negative, yeah, because g minus kv square by m when differentiated will be negative, so I forgot to add minus here. This is minus, okay, and minus log of g minus m by 2k, this is s2. So we have minus m by 2k log of 1 minus kv square by mg equal to, what was s2? S2 was equal to s1, and this was equal to m by 2k log of 1 plus kv naught square by mg. So this gets cancelled out, right? And we can transfer this over here. Okay, actually what happens in log is, you see, a log b. How can we write this? We can write this as log of b to the power a. This is basic log function, a log b equal to b to the power a. So here it is minus 1 log this. So this can be written as plus log of this power minus 1. Alright, log gets cancelled out. So we have 1 upon 1 minus kv square by mg equal to 1 plus kv naught square by mg. And now how will we solve this? we can solve this expression. We can take this whole expression down. We have 1 minus kv square by mg equal to 1 upon 1 plus kv square, kv naught square by mg. And we can take this expression on right hand side and this on left hand side. So we get 1 minus 1 upon 1 plus kv naught square by mg equal to kv square by mg, and this comes here, 1 gets cancelled out, so we have kv naught square by mg divided by 1 plus kv naught square by mg equal to kv square by mg. K and mg gets cancelled out, so we have final velocity is v equal to v naught divided by 1 plus root of 1 plus kv naught square by mg. This is the answer of final velocity. Alright, this is the final answer. Okay, so guys, this was my analysis. I will be posting more videos on gravity, center of mass, rotation, and then we'll move on to other topics. Okay, please like, comment, view, and that's it for now. Okay, thank you very much.